two more problems to do out of section 3.2. The first one's number 60 here, and I didn't clip the instructions when I copied it over to that piece of paper, but the instructions were to graph the logarithm. So I'm going to graph this logarithmic function. One of the things we need to know to be able to do that is the base of this logarithm, and without a base stated, that's the common logarithm, so the base is 10. All right. Well, when I graph logarithms, I kind of want to know what happens when the inside here is 10. I usually think about plugging in the base. But since I have an x minus 2 in there, to make the inside be 10, I actually need to plug in a 12, right? Because 12 minus 2 is 10. And so very secretly, I was kind of thinking about maybe even like solving that equation where I add 2 to both sides and I get a 12. I also like to see what happens when the inside of logarithms equal to 1, because I know I get a 0 out. So I want the inside to be equal to 1, and that happens at 3. And then the reciprocal of the base 1/10. Well, that's going to happen at 2.1, which I'm going to write here as 21 over 10. Okay, well, let's plug those in and see what happens. You plug in a 12, you get log base 10 of 10. Plug in a 3, and you get the log base 10 of 1, which is 0, and you plug in 2.1. 2 and 1/10, you take 2 away, you get the log base 10 of 1/10, which is minus 1. And now I'll be able to plot this point and sketch a graph of the logarithmic function. And that'll just give us one problem left to do. All right. Have to count up to 12 here, and then I just have a 1 and a minus 1 here on the y-axis to worry about. All right, well, a logarithm of x has a vertical asymptote on the y-axis at x equals 0. This is a shift to the right 2 units. So here's my vertical asymptote. And now I can just plot these points. At 2.1, so just almost on that asymptote, just barely to its right, I get that point down at minus 1. 3, 0, and go all the way to 12 and up to 1. And there's that logarithmic function. Oh, I'm going to write its domain down just because I feel like it. I'm going to write its range down just because I feel like it. So that gets us through problem number 60. The only problem we have left now is number 119. And it's an application problem involving a logarithm. Students in a psychology class took a final examination. As part of an experiment to see how much of the course content they remembered over time, they took equivalent forms of the exam in monthly intervals thereafter. The average score for the group f of t after t months was modeled by this function. And then t is told to us to be trapped between 0 and 12. So they only did this for 1 year. And so there's the domain of this application function. Even though logarithms could go on forever, this one won't. We're trapped between 0 and 12. Part A asks, what was the average score on the original exam? Well, that's at f of 0, right? That's that initial point 0 months after they took the exam, right? In that one moment in time. So if 88 minus 15 times the natural log of, well, 0 plus 1 is 1. Well, the natural log of 1 is 0, so we just get 88. The average score initially was 88. Well, I'll be thrilled if I see that final score in any of my classes. That's a wonderful average score on a final exam. Part B, what was the average score after 2 months, 4 months, 6, 8, 10, and 1 year, so 12 months? Since I'm going to be answering a whole bunch of these, I think I'm going to summarize the answers in this table. All right, where I'll be plugging in and getting a decimal approximation, and I think I'll round to 1 decimal place. So I'm going to get out my TI-83, and I've actually already entered this function in. Now be careful, our calculators don't know what t is when they're graphing functions, so we just use x. So now I'm going to go into the table And I have my table set up so that I can type in the values I want to plug in. So I've already typed in 2, 4, 6, 8, 10, and 12. And I went around just to one decimal place. So 71.5, 63.9. As you'd expect, as time goes on, less and less of the material is retained. I assume they're not studying, because then you should be retaining about what you already did. I think the point was just to see how much you naturally forgot. All right, so that answers part B, right? I think, these are exam scores. Maybe they should all be percentages. I always like using units, and these look like percentages, percent scores on the exam, so I'm going to go with it. And then we're asked to sketch the graph of f either by hand or with a graphing utility. Well, since I have all these points, I'm just going to go on and graph it by hand. So I have an axis for time, and then I'll have an axis for their grade. The axis for time is in months. All right, well, I just need to count by twos here. 2, 4, 6, 8, 10, 12. There's 1 year. On the vertical axis, we could choose to count by whatever we want. I'm going to choose to count by 20s. All right, so let's plot all the points we have, starting with the initial point. I did the thing where I wrote off camera again, but I was just counting by 20s up that y-axis. So at 0, 88%, somewhere about right there. 2 months later, 71.5. So let's see, 70 be right there, so 71.5. 4 months, 64. So let's see, that would be 70, 65, and then 64, maybe somewhere right there. 58.8, so 59-ish, so somewhere about there. 8 months, 55. So 60, 40, 50, 55, about right there. 52. And finally, just almost exactly 50. And so I see this logarithmic shape where it's falling down. I wish that was a little better done. I did a little bit nicer job in my notes there, seeing that kind of graph go down, remembering to only go between 0 and 12. One interesting thing to see is if this had no context, there'd be a vertical asymptote over here at -1, and then this would keep decreasing forever and ever. But those are the problems I wanted to do this week, so that's it for now.